Yeah, let me just give you a brief outline about the talk. I will give a very brief company overview to tell you who LaTeX is. Then I'll briefly cover the motivation and the challenges in crosslink measurements. I will introduce our tool to give you a basis for the following slides. And afterwards, we'll look at the applications of the crosslink. The core markets, also as Miguel just said, is epitaxy processes. So LaTeX grew big with the introduction of LEDs in the industrial production. Later on, laser and power devices followed, and about a bit more than just very quickly about the impacts on lamination quality. So actually, this is a twofold impact. There can either be inhomogeneous peroxide content along an EVA roll, so the raw material that you use for your encapsulation process. On the upper left here, you can see this is the cross-linking tool in its manual operation mode. So it's a standalone tool where the operator can place the module on a roller table to position the measure, or to go to the desired measurement position, and then conduct the measurement just by pulling this handle here. Everything afterwards is completely automated. And then a measurement is conducted, which is completely non-destructive. The test duration is somewhere between 10 and 60 seconds per measurement, with a precision up to 3%. It works for all types of backsheet modules with a cross-linking encapsulant, even though it will require a calibration process to really come up with an absolute gel content number. Otherwise, it will just provide. So what's the mechanism behind it? The trick is that we're actually not doing just an indentation measurement, as it's usually done in polymer science or any rheological measurements, but that we're doing a thermomechanical one. This means we're heating the sample as it is measured by indentation, and above a certain melting, which is actually the melting point of the pure EVA material, and above this temperature, we do see a clear split up of the. Of course, if one is talking about an indentation measurement on such a fragile device like a PV module, one may be scared that we do some damage to the cell. And of course, we were concerned about that in the very beginning, but we did a lot of tests with different institutes when the tool was developed. Obviously, we're not in the year 2014 anymore, and polyolefin has become a very important material. And this is to show you that it also works for cross-linking polyolefins as encapsulant. So what we see on the left-hand side is, again, the result of a 9-point measurement on a one-cell mini module after 15 minutes of lamination and 30 minutes of lamination. This is now a very busy slide, and I'll be happy to provide it afterwards, so you can plug in your numbers. But I would just briefly want to stress the economic value of such a metrology method. So basically, what you have to take into account either the value of the PV module that you destroy, or the effort for producing the mini module that you produce as a twin, the cost for the SOX-led analysis, which would be a typical scenario for maybe developers that are building a PV site anywhere where they have to use several hundreds or several thousand modules. And most of the time, they might have known which module they ordered, and they might have some idea of the bill of material, but they cannot be sure that if it's really the bill of material they ordered, and they will very often not know the particular materials in the module. So in that case, we think there is still some value in the module, in the system, because I think you can always start with the assumption that a low homogeneity.
Visit Sinovoltaics.com to learn more.